Hello, this is Jeffrey. Welcome back. And the topic we're going to be discussing today is linear equations in one variable. In this section, you will learn to solve equations in one variable algebraically, also solving a rational equation, finding a linear equation, also when you're given equations of two lines, determine whether their graphs are parallel or perpendicular to each other. Alright, so let's start off with solving linear equations in one variable. A linear equation is an equation of a straight line written in one variable. The only part of the variable is 1. Linear equations in one variable may take the form ax plus b is equal to 0 and are solved using basic algebraic operations. We begin by classifying linear equations in one variable as one of the three types: identity, conditional, or inconsistent. An identity equation is true for all values of the variable. Here's an example of the identity equation. 3x is equal to 2x plus x. Okay. The solution set consists of all values that makes the equation true. For this equation, the solution set is all real numbers, because any real number substituted for x will make the equation true. Right? For instance, if you plug in 1 for x, you got 3 is equal to 2 plus 1, which is true. If you plug in 2 for x, you got 6 is equal to 4 plus 2, which is also true. Right. The second type is called the conditional equation, which is only true for some values of the variables. For example, if we are to solve this equation, 5x plus 2 is equal to 3x minus 6, we have the following. Alright, let's first set them equal to each other. So we got 5x plus 2 is equal to 3x minus 6. And then if we subtract 2 on both sides, and also 3x on both sides, we got 2x is equal to negative 8, and then we can just divide by 2 to solve for x. We will get x is equal to negative 4. The last type of the equations are called inconsistent equation, which results in the false statement. For example, if we are to solve 5x minus 15 is equal to 5 times x minus 4, we have the following. We'll get 5x minus 15 is equal to 5x minus 20, which is not true, because if you subtract 5x on both sides, you'll get negative 15 is equal to negative 20, which is obviously not true. So this type of equations are called inconsistent equations because they are just false and not true. Alright, so the second one is solving a rational equation. In this section, we look at the rational equations that, after some manipulation, result in a linear equation. If an equation contains at least one rational expression, it is considered a rational equation. Recall that rational number is the ratio of two numbers, such as 2/3 or 7/2. A rational expression is the ratio or quotient of two polynomials. Here are three examples. The first one, x plus 1 over x squared minus 4. The second one, 1 over x minus 3. Or the third one, 4 over x squared plus x minus 2. Rational equations have a variable in the denominator in at least one of the terms. Our goal is to perform algebraic operations so that the variables appear in the numerator. In fact, we'll eliminate all denominators by multiplying both sides of the equation by the least common denominator, or the LCD. Finding the LCD is identifying an expression that contains the highest power of all the factors in all of the denominators. We do this because when the equation is multiplied by the LCD, the common factors in the LCD and each of the denominator will equal to 1 and will cancel out. Alright, the third topic is finding a linear equation. The slope of a line. The slope of a line refers to the ratio of the vertical change in y over the horizontal change in x between any 2 points on the line. It indicates the direction in which the line stands, as well as its steepness. The slope is sometimes described as rise over run, right? So look at this graph. This is the equation to solve for slope. And let's look at this graph as an example. To solve the slope for this red line, we first have to note at least 2 points from this graph for this line. We got 0, 2, which is here, and also negative 1, 0. plug it in back into the equation. M is equal to y2 minus y1 over x2 minus x1. We got our y2 right here, which is just 2, and the y1, 0, x2, 0, and then x1, which is negative 1. Alright, so if we plug all these numbers into that equation, we got 2 minus 0 over 0 minus negative 1. So we'll get our slope, or the m, is 2. So the slope of this line is 2. Given the slope and 1 point on the line, we can find the equation of the line using the point slope formula, where y minus y1 is equal to m times parentheses x minus x1. This is an important formula as it will be used in other areas of college algebra and also oftentimes in calculus to find equations of a tangent line. We need only 1 point and the slope of the line to use this formula. After substituting the slope and the coordinates of the 1 point into the formula, we simplify it and write it in the slope-intercept form. Alright, so this is the point slope form, or the point slope formula. Anyway, and this is the slope-intercept form. Right, y is equal to mx plus b, and the other form is standard form. Ax plus by is equal to c, which like all a, b, c are all just constants. Yeah. The last one is determining whether graphs or lines are parallel or perpendicular to each other. Just notice that the most simple way to determine whether it is parallel to each other or perpendicular to each other is just using this formula. If they are parallel, like two lines, if they are parallel to each other, they got same slope. They just got different like constant at the back. For this graph right here shows like 3 lines that's parallel to each other. Notice that they all got the same slope of 2, right? They just got different constants at the back. So if 2 lines are parallel to each other, they must got the same slope, okay? Yeah. And on the other hand, if 2 lines are perpendicular to each other, the product of their slope must be equal to -1. In this case, if we look at the graph right here and focus on the red line right here, y is equal to 3x minus 1. If we want to find the slope or the equation for the line that's perpendicular to this line, we simply gonna plug in the slope of this line, which is 3, back into this equation. So 3 times x, or m2, the slope of the second line, is equal to -1. In which case we find it like m2 is gotta be equal to -1/3. So yeah, the equation or the slope of this line that's perpendicular to that for this red line is gotta be -1/3. And the constant at the back doesn't really matter. You can put it like +7 or even just 0. It will still be perpendicular to that one. As long as the slope, the product of their slope, is -1, they'll be perpendicular to each other. So the constant at the back doesn't really matter. Yeah. Alright, so let's do some practice question. Practice question number 1. Solving an equation in one variable. So just solve this. 2x plus 7 is equal to 19. I'll give you guys 20 seconds to work on this one, starting from now. Alright. Here's the solution. So we first subtract 7 on both sides. So we get 2x is equal to 19 minus 7, which is 12. Right here. So then we can just divide by 2 on both sides. So we will get x is equal to 6. And if we plug that back in, x is equal to 6. Alright, 12 plus 7 is equal to 9, which is true. So yeah, this is the solution. Question number 2. Finding the slope of a line given 2 points. Just find the slope of a line that passes through the points 2, -1, and negative 5 comma 3. I'll give you guys 30 seconds starting from now to work on this one. Yeah. Alright, here's the solution. If we use the formula m is equal to y2 minus y1 over x2 minus x1, we just plug these numbers in, right? So the y2 is 3, y1 is negative 1, so 3 minus negative 1 on top over x2, which is negative 5, minus x1, which is 2. So the m is equal to 4 over negative 7, right? So the slope is negative 4 over 7. Last question, finding the equation of the line passing through the given points, right? The points is 1 comma negative 3, and also 1 comma 4. I'll give you guys 30 seconds to work on this one, starting from now. Alright, if you use the formula, the slope formula for this one, you'll get 4 minus negative 3, so 7 over 1 minus 1, 7 over 0, which does not exist since the denominator cannot be 0. So in this case, the slope doesn't exist. So the equation for this line is simply just 1. X is equal to 1, because like x passes through both of the points, but there is no slope. So we got the equation for this line is just a vertical line, x is equal to 1. Alright, and that's it for today. Thank you.